Hello friends, welcome you all in my page online chemistry tutor. Please see the video till end. Please like the video if you like it. Please dislike if you dislike it. Please comment why you dislike it so that we can improve our video further. Today what we will discuss is acid base concept, basic concept of acid and base. We know acids and base are very popular chemicals in our chemistry, and to determine one particular substance as acid or base, there are four different concepts by scientists how you can define one substance as acid or a base. Number one, Arrhenius concept. Number two, Bronsted Lowry concept. Number one, Arrhenius concept. Number two, Bronsted Lowry concept. Number three, Lewis concept as per scientist Lewis. And number four, Lux Flood concept. We will discuss all these concepts in this video. So let's start. At first, Arrhenius concept of acidity and basicity. What does Arrhenius concept tell? Arrhenius concept is very basic concept of acidity and basicity. According to Mr. Arrhenius, acids are hydrogen containing compounds. Hydrogen containing compounds means the acid have hydrogen in their structure, and not only that, but capable of giving protons in aqueous media. Aqueous media means in water medium. When we dissolve an acid in water medium, what does it do? It will give protons, and if it gives proton, then we will describe it as an acid. Next, base. Bases are compounds which can produce hydroxide ions in aqueous media. In aqueous media means that when bases are dissolved in water, they will produce hydroxide ion, OH minus ion, in aqueous media. Okay. Next, we'll describe this concept further. Let us take an acid, HCl. HCl is a very famous acid, and if we dissolve HCl in water, what does it do? It will produce H plus Cl minus. This H plus bonds with H2O and produce H3O plus. Okay, so HCl, when HCl dissolve in water, what happens? It produces H3O plus Cl minus. As H plus cannot stay in water, it will form bonds with H2O and form H3O plus. According to Mr. Arrhenius, what happens? Now, hydrogen containing compounds capable of giving protons in aqueous media. Now, in protons in aqueous media forms this H3O plus or hydroxonium ion. Okay, and this hydroxonium ion produce. So this is an acid, and so we can describe it an acid. According to Mr. Arrhenius, what happens? Hydrogen containing compound, we can see this compound contains hydrogen, and in aqueous media it gives proton. In aqueous media or in water media, what does it do? It will give protons. Okay, so this is an acid. Next example, H2SO4, the very famous acid, sulfuric acid. When it dissolves in water, this compound contains hydrogen, so this first condition satisfied, hydrogen containing compound capable of giving proton in aqueous media. We'll see in aqueous media what happens. H3O plus plus HSO4 minus. In first deprotonation happen. Next step HSO4 minus plus H2O. It will give H3O plus SO4 2 minus. So a hydrogen containing compound produce proton in aqueous media. So this is an acid. Okay. Our next discussion. Next are bases. Now what are bases? Bases are compounds which can produce hydroxide ion in aqueous media. Now famous base sodium hydroxide, which on aqueous media which produce Na plus and OH minus. This is ionic compound and this breaks into these two ions. When we dissolve NaOH in aqueous media in H2O, what happens? It breaks down Na plus OH minus. Just H2O. This is medium. Okay. This medium remains, and it a base containing hydroxyl ion, and it produce OH minus ion in aqueous media. So this is a base. Next example, CaO. When dissolved in water, it produce Ca2 plus 2OH minus. A base which produce OH minus in aqueous medium is a base which can produce hydroxide ion OH minus in aqueous medium is a base. So this is a base. Okay. Next, NH3. When it dissolves in water, it will produce NH4OH, and it breaks down into NH4 plus OH minus. A compound in aqueous media produce OH minus is a base. So this is a base. Okay. So these are the basic concepts of acidity and basicity. These are acid and these are bases. Okay. Now a common question arises. All that are bases are alkalis, and but not all the alkalis are bases. So we have to define what is alkali and what is bases, and basic differences between alkalis and bases. Alkali, bases. Alkalis are compound which produce OH minus when dissolved in water. They are bases. Means all the compounds of electropositive metals or elements are alkali. All the oxides compounds of the electropositive are alkalis. Okay, and in between these, those which dissolve in water are bases. All the compounds does not dissolve in water which dissolve in water are bases. Those which does not dissolve in water are not bases. They are only alkalis. All the compounds of electropositive metal, all the oxide compound. Okay, not all the compounds, all the oxides. All the oxides of electropositive metals are alkalis, and in between those alkalis dissolve in water are bases, those does not dissolve in water are not bases, they are only alkalis. So you can see the Al2O3, this is an alkali, this does not dissolve in water, so this is not bases. Okay, this is only alkalis. AlOH whole thrice, Fe2O3 or FeOH whole thrice, this does not dissolve in water, so this is not bases, this is only alkali. Okay, NaOH or Na2O, K2O, KOH, these are alkalis and they dissolve in water, so this is bases also. So they are both alkalis and bases, but these are only alkalis, not bases. So we can often say that all alkali are bases, but all bases are alkali, bases are alkalis, but all alkalis are not bases, because those alkali does not dissolve in water are not bases, those bases only alkalis which dissolve in water. Okay, these are the basic differences between alkalis and bases. Alkalis may be dissolved in water or may not be, but base should be dissolved in water, and when they dissolve in water they are termed as bases. They can be termed as alkalis also, but when some alkalis does not dissolve in water, say they cannot be described as bases, they have to describe as alkali only. So all bases are alkalis, but all the alkalis are not bases. Okay, next, Bronsted Lowry concept. This concept is very important concept in our discussion. Acids are proton donors. Those compounds which donate protons are acids. Bases are proton acceptor. Those compounds which accept proton are bases. Next, take an example. H2SO4. What does it do? This produces H plus HSO4 minus. So this compound removes proton or donate a proton product. Okay, and so this compound donates proton and this is acid. Okay, next, HCl, H plus Cl minus donates proton to someone others, so this is a acid, this is an acid. Bases are proton acceptors, means those who accept proton are bases. OH minus, so NH3 plus H plus, what happens? NH4 plus. So this is the compound which accepts proton is a base. This is a compound which accepts proton and from this NH4 plus, so this is a base. Okay, accepting protons is a base. So bases are proton acceptors. Okay, now you can see a compound like OH minus. What does it do? It accepts proton and forms H2O. So OH minus is a base. This is a base as it accepts a proton. Okay. Each accept proton and form H2O, so this is a base. Now this is a compound. Look at this compound. This compound can break through NH3 plus H plus. So this compound can break through NH3 and H plus. So this compound can donate proton or product obtained. So this is an acid. This is an acid. This is a base. Look it carefully. We'll go to next page. We know that bases are proton acceptor. So NH3 plus H plus, what happens? NH4 plus. This compound accept a proton and forming this. So this compound accept proton, so this is a base. Now this is a compound NH4 plus. What does it do? It will break into NH3 plus H plus. So this is a compound which donates proton. So this is an acid. So bases when accept a proton form an acid, and acid when donate a proton form a base. We'll discuss it further. Base accepting proton forms an acid. Acid releasing a proton form a base. So these two acids and bases are termed as conjugate acid base. Okay. This acid is a conjugate acid of this base, and this base is conjugate base of this acid. Okay. So this is Bronsted Lowry concept, is often known as conjugate acid base theory, and so this theory is very much important. We will discuss it further. Our next concept is Lewis acid base concept. Acids are lone pair of electron acceptor, bases are lone pair donor. Now we will discuss it further. NH3. If we see the structure, the nitrogen has a lone pair. This is BH3. If we see the structure, then we can found that boron has 6 electrons in his valence shell. The 2 electrons remaining to be fully octet. So NH3 and BH3 form bonds through this lone pair donation. What happens? This lone pair donates to BH3 and forming this compound. So here NH3 donates the lone pair of electrons, so this is base, and this bases are lone pair of electron donor. So donor is NH3, so this is base, and this BH3 accepts the lone pair. Acids are lone pair acceptor, so BH3 is an acid. Okay, so these are Lewis concept, acidity and basicity. Next, Lux Flood concept of acidity and basicity. Acids are oxide ion acceptor, bases are oxide ion donor. All the relations we have discussed so far are containing hydrogen donor, hydrogen acceptor, etc. etc. But this Lux Flood concept is a concept containing oxide ion donor acceptor concept. we can discuss an equation CaO plus SiO2. What happens? CaSiO3. Actually the relation is Ca2 plus SiO3 2 minus calcium silicate. This is silica, this is calcium oxide, okay, and this is calcium silicate. Now in this structure what happens? This calcium oxide forms calcium 2 plus, oxide ion donates, and this silica forms this silicate, oxide ion comes, acceptor. So oxide ion acceptor is an acid, so this accepts the oxide ion, so this is an acid, and these bases are oxide ion donor, so this donates the oxide ion, so this is a base. Okay, so this is acid and this is base. That is the concept of Lux Flood concept of acidity and basicity. Now we will discuss some further relations about this conjugate acid base theory, the Bronsted acid base theory. This is very important theory, Bronsted concept, and for this relation we have to go further describing on this relation. So we discuss this relations further. What we have discussed is conjugate acid base theory. In this theory, this is the base which accepts hydrogen plus and forms an acid. This is the conjugate acid of this base. When this conjugate acid donates its H plus, it will form NH3, and this is the conjugate base of this acid. Okay, now just imagine that what is the we will going to discuss what is the energy of the of this acidity and basicity, how the acids are strong, how the bases are strong. All this we are going to discuss here. Now now just imagine that this accepts H plus very quickly. So what happen? This will forms very much, and the chemical equilibrium constant equal to, according to our law of mass action, what happens? This is NH4 plus by NH3 into H plus. Okay, NH4 plus NH3 into H plus. So we discussed that this is a very strong base. Very strong base means it accepts proton very easily. So the in equilibrium constant, the concentration of these two will be very small. So this will be very small. So K will be very big. K will greater than 1. So K will be very big. Now discuss about this equilibrium. What happens? K equal to NH3 into H plus by NH4 plus. If this is very big, this is very small, so K should be, this is very small, okay, and this is very big. So what happens? K should be less than 1 here. This is K1 for first equation, K2 for second equation. Okay, as K2 is 1 by K1. So this is very less than 1. It means that this will breaks down very slowly. What does it mean? This means that when a base is very strong, its conjugate acid is very weak acid, and when a acid is very strong, its conjugate base will be very weak. Okay, that's a vice versa relation. Strong base weak conjugate acid means when a base is very strong, its its conjugate acid will be very weak. Why? Because of this relation. Okay, this K1 is greater than 1. If then K2 is should be less than 1, means this equilibrium will be further in the left hand side. So this does not break down, and so this is weak. If an acid is very strong acid, its conjugate base will be very weak conjugate base. So this is vice versa relation. If acid is very weak, then its conjugate base is very strong. If acid is very strong, its conjugate base will be very weak. If base is very strong, its conjugate acid will be very weak. If base is very weak, then its conjugate acid will be very strong. This vice versa relation happens. Okay, this is the discussion of acidity and basicity in very basic level. We will discuss pH, pK, pKb, all this in our next video. Thank you.